Hello world, my name is Victor Engelmann. Welcome back to the series on professional network design using Linux. Today I want to talk about LDAP, the Lightweight Directory Access Protocol. Well, lightweight. First of all, what is LDAP? Basically, LDAP is a database. Okay, it's a system that will just take data from you and store it and give you ways to access it later. But yeah, in reality, it is mostly used to store login informations. Okay, and a lot of programs are able to use this such an LDAP server as a backend for their authentication process. Okay, so when you have an LDAP server, you might take your SQL server and attach it to the LDAP server so that then you can manage your passwords for the SQL server on the LDAP server. And when you have multiple things connected to it, like a radio server, a VPN server, whatever, the benefit is that your users have the same username and password on all the systems that are connected to it. Okay, so they don't have to remember multiple passwords. They don't have to do the password cycling on all your systems separately. And yeah, that just makes things easier to manage. But on the other hand, when you look into tutorials online on LDAP, you get the impression that LDAP is pretty complicated, but yeah, I don't think it's that complicated. I just think these tutorials are bad. Okay, so yeah, let's talk about some fundamentals first. What is LDAP? Well, LDAP fundamentally just manages an attributed tree. Okay, and yeah, as programmers nowadays, when we hear attributed tree, we say, well, with some of the standard classes that you get with every programming languages these days, writing an attributed tree is a thing of 10 minutes maybe. And yeah, but still, LDAP fundamentally is just an attributed tree. Okay, so you have such a tree-like structure with a root and child nodes, and all of these nodes have something like a table with entries that have a name and a value, like foo, and might have the value bar, and buts has the value xyz, whatever. And if you're now thinking of a directory structure, that's very much the same thing as a directory structure, yes. Like here you have the directories, and well, the names here are very similar to the names of files, and then the value could be the content of the file in that directory. Okay, actually the same name here on the left can have multiple values on the right, so that's very much like a file that has just multiple lines. This tree, by the way, is called the DIT, the Directory Information Tree. Now, if you think about this in terms of directories and files, then of course the question is, how do you reference these different objects here? And well, in a file directory, you would have just a file name, you know, like /home/ your username /something, for example. And yeah, it's similar here in LDAP. Every node has a so-called distinguished name, DN, and I'm not sure if it has to be, but I've never seen it any different way, so it probably has to be just some entry here from this table. Like something that you will often see is you have something like a CN, which stands for common name. Let's say Victor. And then you would reference this through the name CN equals Victor. Okay? So that would be something like the distinguished name of this node. Okay? And when you have something that's further down, like you might have something like DC equals local, DC equals Engelmann, and then something like OU equals users. This is written right to left, so if you want to reference this node here, then you would take the first level, DC equals local, comma, DC equals Engelmann, comma, OU equals users. Okay, so this would be the distinguished name of this node. Now attributed trees are very dynamic, right? You can just create nodes and nodes and nodes and more and more and more nodes, and in these directories you can have files, and the files can have lines. But if you want to work with these things, then having so much freedom is actually a bad thing, because you cannot rely on things being there that you expect to be there. And yeah, in reality, let's say you have a user here with UID equals root, for example. Now, if you want to do anything with this root object here, you don't want to look into the table all the time and ask, hey, do I have a home directory? Do I have a shell? Do I have a password? Whatever. So you don't want to test all the things all the time. And imagine you have multiple programs that interact with your LDAP server. Then yeah, you don't want to test these things all the time in all your programs and everything that accesses this tree, right? And because of that, you can impose limitations on these objects. So you can give objects a so-called object class, which is another entry in this list here. So object class, in camel case with a big capital C. And yeah, if you give a node such an object class, then the LDAP server will compare the object to a class. So if you give it, for example, the class inet.org person, is very common. So if you give this object the class inet.org person, then the LDAP server will look into the class inet.org person and see, well, every object of this type must have a name, for example, a password, an email address, whatever. And yeah, the LDAP server will then just refuse to take objects that don't fit these classes, okay? And that makes things easier for us when we are programming things, because we can just say, hey, I'm querying for inet.org persons, and every object that I'm getting back must have all these attributes, and then I don't have to ask them all the time, do you have this attribute, do you have this attribute? We can just access these things. You can even put restrictions on the values that you are allowed to put in these objects using so-called schemas. But yeah, actually writing these classes and schemas is relatively complicated. Because of that, yeah, most companies don't even bother. In theory, you can write your own classes, your own schemas to do whatever you want. But again, this is relatively complicated, and because of that, most companies will just use the standard classes like inet org person, domain component, organizational unit, stuff like that. And yeah, inet org person, for example, is the class with which Active Directory stores its user accounts. Now, when you have such a tree, of course you want to do things with it, right? Because why have it otherwise? And to interact with your tree, you use so-called LDIF files, which stands for LDAP Data Interchange Format. And yeah, these files are a bit unwieldy, but you get used to them. They look like this. They start with a DN colon, which yeah, is a distinguished name, so you have to say where in your tree you want to do something. And they cannot be relative. They have to be the full path from the root to the thing that you want to interact with. So for example, in this case, OU equals users, comma, DC equals Engelmann, comma, DC equals local. Okay? And then you have to say what you want to do there by specifying a change type. In camel case, change type colon add, for example. And then, yeah, you just have to specify what you want to add. Now this thing we already have, so if I want to create a new user, let's say UID equals Victor, then actually this DN is not enough, because you have to go down to the thing. When you want to create something, you have to specify the path to the thing that you want to create. So the DN would then have to be UID equals Victor, comma, OU equals users, and so on. Okay, change type add. And then you put the classes here that you want to put in there. So object class. The classes actually have some form of inheritance. So if I want to create an inet org person, in my opinion, it should be enough to say inet org person, but that's not the case. You actually have to list all the parent base types also. And in case of object class inet org person, this is derived from organizational person. And from person. Okay, so you have to list all the base classes also, which again, in my opinion, doesn't make sense. It should be easier, but that's the way it is. And yeah, then you just list all the things that you want to be in there, like a common name, Victor, user ID, Victor, yeah, and whatever, mail address, telephone number, whatever INET.org person requires. But yeah, that's what an LDIF file looks like. Normally you have a distinguished name, then a change type, and below that you typically just describe the object that you want to put there or the changes that you want to make. It's really the first two lines that specify what you are doing. Okay, and the rest clarifies how you want to do that. For example, a different thing you might want to do is you might have a change type modify. So we are talking about an object that already exists, and we modify it by adding a value, like, I don't know, let's say shell. And then in the next, so change type modify, add, I want to add something, a value named shell, and then I can put the value here, like in bash, for example. You can do multiple changes with the same LDIF file. That's actually a bit stupid, but if you want to make multiple changes, then you just put an empty line between the changes, okay? So you have one change, an empty line, the next change. This has the disadvantage that you cannot have empty lines within one change. Yeah, we'll have to live with that. If you want to have some space in between, then you just have to put this pound sign, the comment character, so that you comment out this empty line effectively. Okay, for completeness you can also have distinguished name, whatever, change type, delete, which deletes the object and all child objects. So this is how you can edit your tree. You can create, update, and delete things. So in this CRUD model, create, read, update, delete, what is left is reading. So how do we get data out of this thing? That's done with so-called queries. Yeah, queries are just things like open parenthesis, UID equals Victor, for example, close parenthesis. That would be a query. So it would look for objects that have this property. I mean, some things don't have to be unique, like usernames. You might look for things that for users that have been bash as a shell, for example. You can also use star, but I think you can only use that at the beginning or end of the query. Yeah, and you can combine queries with logical operators. You can have open parenthesis and query, 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 and so on. This combines all these queries, and you are looking for objects that have all these properties. With a pipe is the OR, which means that you are looking for something that has one of these properties, and with an exclamation point you can negate a query, so you are looking for things that don't have this property. Okay, so let's start working with LDAP now. For this, I've again prepared a Raspberry Pi, and I will connect to that. Okay, now I'm logged in on that server, which has a hostname LDAP server. And yeah, I will start by installing the package slapd. That's the LDAP server and also LDAP-utils. Now, when you install it, it prompts you for an administrator password. I will set it to super secure. Confirm super secure. It sets up a few things. It creates a user, open LDAP, and creates a directory. Now, a lot of how-tos out there on the internet tell you to just install the LDAP server slapd, and it would automatically start a configuration tool. But yeah, here it just hasn't happened for whatever reason. So we can manually start that configuration using sudo dp kg reconfigure slapd. Okay. Here we have to select no, we don't want to skip the configuration. And yeah, we have to set a domain name. I will set it to engelmann.local. I think it has picked that up from the domain name that my DHCP server has given to the Raspberry. Okay, the organization name is, I think, just a free text string, but I will set that to engelmann.local also. And yeah, set the administrator password. I think you could make a new password like this, but super secure. Super secure. Do you want the database to be removed when slapd is purged? No. Well, there's already a default database. We will move that to some other location. And yeah, now we have a running LDAP server. We can confirm this with sudo system control status slapd. It says it's active, it's running. So yeah, now we might want to connect to this and do something with it. For this, I will do this on my laptop. Now there's a lot of client programs to work on LDAP servers, but yeah, in my opinion, they are all not very good. Yeah, the Microsoft Active Directory management tool is maybe the best one of them, but for this video I'm going to install a program called Apache Directory Studio. That's in the AUR packet sources. So let's build it. Okay. Let's start this Apache Directory Studio now. Okay, it has successfully launched. You might run into problems here because Apache Directory Studio is Java-based, and if you don't have a JDK installed, like OpenJDK for example, then this will just fail to start. So keep that in mind. This needs a JDK. Okay, when you first start it, it looks like this, and I find that not really helpful. So to get to a useful point in this program, just close this welcome screen. Okay, and now you have a much better view here, where you have down here you have a list of servers. Here you then have, when you've connected to a server, you will have the tree. You can explore the tree and log informations here and informations about the currently selected node in your tree here. Okay, so let's connect to our Raspberry Pi. So with this button I create a new connection. To my LDAP server. The host name is LDAP server, port 389. No encryption for now. We have to select a user, and this is really confusing here because you need to use the LDAP distinguished name of a user, and you don't know where that user is located inside your tree. And I will tell you it's the common name equals admin, comma, in domain component equals, and now the domain name that you've entered when you set up the server, so Engelmann, comma, DC equals local. Remember, this is top down, right? So local is the first node in this tree. Then below that you have a domain component object named Engelmann, and below that there is a user called admin. And the password that you put here is the one that you've set when you've installed the server. So this is super secure in my case. Here with this button you can test if the settings are okay, and it says here authentication was successful, so the settings that I've made are good. You can set a base DN, distinguished name, where you want to start, but I will just click finish. And now down here you have this server connection, and if you now close the program, start it again, there you have this connection again, and double click it, now you are connected again. The DIT is the directory information tree, that's your tree here. And here is your domain engelmann.local. And now we can start editing this tree. For example, we can create some organizational units that you may know from Active Directory. Organizational unit, and I will give it the
value OU equals users, and then the distinguished name is OU equals users, comma DC Engelmann, comma DC local. Okay, now we have this organizational unit. Now we'll make another one. Named groups. Okay, that's a pretty common way to set up your LDAP server. And yeah, in here you could now create new objects. Typically inet org person. That's a common class used for user accounts. There the relative distinguished name is typically used with cn equals and then some username, like Victor here in my case. Okay, inet org persons must have a value for sn, which is the shorthand for surname. Yeah, my surname is Engelmann, so okay, now I was allowed to create that user. Let's make another user. Inet org person. Cn equals Ramona for my wife. Okay, now I've created two users, and yeah, here in groups, when you create user groups, you would typically use group of names or group of unique names. Also with common name cn. Let's just create a group named test. And yeah, now we can add users here. Let's say I add myself. Here in this list of members I can now add new values. Browse users Ramona. Okay. Now you see you have now two entries for this member attribute with the full distinguished names of both users in here. Okay. Yeah, I think that's a bit too complicated, because if you want to move users around, you have to update these values. I think Active Directory really does that better, because they have these security IDs, you know, with this s dash some number dash some other number, and that's a unique identifier throughout your domain, and that's indexed. So so yeah, you can just move them around, and you don't have to update your groups, because the groups store these security IDs and not the full distinguished names. To find the full distinguished names through the security ID, Active Directory then uses this index, right? So now let's go a bit into internals, because this is all nice and everything, but I think it's always important to know what's going on behind the scenes. So in var lib LDAP you have this data.mdb. Of course, you also have your typical directory etc LDAP, in which you have your LDAP conf. Okay, not much in here. But more interesting than that, I think, is the directory etc LDAP schema, where you have these schema files and LDIF files. Okay, and for example, you have this inetorg person.ldif. Remember, inetorg person was the class we used for users. So let's look into that file. Okay, this is a bit squeezed together. Let's look into the schema file instead. Okay, this is more readable, I think. Here you have the definition of your attributes. So these are the things that you can add to your objects. Right? Also, for example, this is for inetorg person. And an inetorg person can, for example, have a field called car license. So if I start Apache Directory Studio again, then I can go to my inetorg person objects and give them an attribute. So here I could now say add attribute car license. Okay, and it already suggests this value here, this name, and then you could put some value here. Okay. Now these attribute type entries here, you see you have multiple entries of attribute type. They start with a so-called OID. That's an object identifier. This is some really old school mainframe stuff. You have similar things in Simple Network Management Protocol, SNMP. There you also have such OIDs, and you can get a prefix for your own company. So you have a unique prefix, and under that prefix you can register your own data types. So the first value in here is an OID under which this attribute should be known, and actually the name is just an alias for this OID. So when you want to add a car license, for example, to your user, you could instead just add this OID. Okay, and that's what the LDAP server internally does when you say, hey, I want to add a car license. The attribute has a name, a description, then these two lines specify how the bytes in memory should be compared, and this syntax entry here, that's kind of the data type of the attribute. Okay, when you compare that to the next value here, for example, so 136, 141, 1466, 115, 121, 115. These are the same syntax OIDs. So these two values have the same data type string, basically. Here we have a value employee number with single value, so an employee is only supposed to have a single employee number. And down here we then finally have the description of INET.org person. You know, INET.org person is not an attribute which you put here. It's a class which you can put into your directory, right? You put these objects with these classes into your tree, and then you can give certain attributes to these objects. Okay, and here this now specifies that INET.org person can have these values. Here car license, for example, and they are separated with these dollar signs. Okay, these are optional values. You can also have an entry must with then attributes that are required. Here this is a superclass, really in the object-oriented sense that an INET.org person is an extension of organizational person. Okay, so we again have an OID for our class, a name for the class, a description. Here we tell it what superclass it has. And notice one thing, these attributes have a name, right? And then you can put these attributes into your classes, right? But the attribute already has its class, its type. So in LDAP it's actually not possible that two different classes have attributes with the same name but different type. That's really stupid if you ask me. Now if you want to know more about these classes, many of these LDAP classes are specified in RFCs. So you might want to check out the RFCs 1274, RFC 2256, RFC 2307 and RFC 2798. These are some important RFCs that specify some important LDAP classes. But as you can see, LDAP classes are actually extendable, but no one really does that. Most people just work with the classes from these RFCs. Okay, now let's also work a little bit with the command line tools. There's, for example, LDAP search. If you don't specify a host name with -h, then it will run on the same host. So if I'm running LDAP search without a host name on my LDAP server, it will work. Here on my local laptop this wouldn't work because I don't have a server installed on the laptop. So let's see, with my default login data with -LLL, I specify that I want the results in ELDIF format. Now with -B I can specify the base DN, so the directory where I want to start running this. So if I want to run this on this organizational unit called groups, for example, then I could say OU equals groups, comma, domain component equals Engelmann, comma, domain component equals local. Okay, now it gives me a list of all the things in this directory. There we have the organizational unit itself and this one group with its two members. Now if I want to do the same thing on my local laptop, well, LDAP search is not installed. So I'll go to the package manager again and install OpenLDAP. Okay, that's a core package, so it should also be installable with pacman-s. Anyhow. Okay, now let's try again. Okay, can't contact LDAP server because it's trying to access an LDAP server locally, and there just isn't a local LDAP server, so we have to set a host name LDAP:// LDAP server, and yeah, this -x is now not needed because that uses internal authentication values. I will use ELDIF format and an output of this directory again. Enter your password. Invalid credentials. Okay, we need to set the username also, and you do that with -D. And we had the user cn equals admin, right? Okay. Server is unwilling to perform, or unauthenticated, no password. So we also have to give it the password. Now we could give it the password with -w and put the password here. Okay, this works. But in a production environment, you wouldn't want to have this value appear in the history, for example. So you can just use capital W, and then it will query you. Okay, now you can put it in here, super secure, and you get your answers. Okay, now let's create another organizational unit. For this I will write a little ELDIF file. Under dc equals Engelmann, dc equals local. In this directory, I will create an object named OU equals test OU with object class top and object class top is the most basic top level class, like object or so in C# or something. Object class organizational unit. With value OU equals test OU. Not sure if we have to put that there, but okay. Now let's execute this ELDIF file on the server. We can do that with we can basically use the same query here. So with -h we specify the server, the ELDIF format. We don't have to specify a base DN because the ELDIF file contains a base DN. But with this user and this password, LDAP add -f test.ldif. Okay, it apparently doesn't require this LLL parameter. Let's try without it. Super secure, add a new entry. And yeah, let's reload. Yeah, now here we have this new organizational unit, so we have successfully added an organizational unit. That's nice. Okay, and the last thing I want to do, I promise, I want to use a filter. So we had this LDAP search on our LDAP server, the results in ELDIF format. Let's search for users. With this user. And with -s base, we can now query, we can now specify what to search for. And let's search for things that have the surname Engelmann. Yeah, okay. So yeah, now without this filter, we would also get the organizational unit, but if we filter now for things that have the attribute SN equals Engelmann, well, this organizational unit doesn't have that, so if we use that filter, then we only get the other things. And yeah, I've already told you how you can combine multiple queries, and so I'm not going to show that again now, because this video is getting long enough. But in Microsoft Active Directory, actually, the PowerShell often has functions that can use such LDAP filters to limit the scope of your PowerShell scripts. So that's pretty useful for doing certain queries on your Active Directory. Okay, so that was a lot of information, but I think it's good to know. I personally am not a huge fan of LDAP because I think it's a bit unwieldy and clunky, but yeah, it's widely accepted, so we still need to understand it and support it in a way. So yeah, whatever. That's all I wanted to show you today. If you liked this video, like it, share it, subscribe, and see you next time.